Welcome to episode 46 in this series where I'm programming a game for the original NES live on stream on Twitch. Let's jump into it here. So last time we were working with the game. We'd gotten things mostly functional. There's a little bit of stutter to the way that the game is playing in terms of how the background is loading. You can see it does like a little bit of a jump. That is not an artifact of the streaming. Excuse me. That is a that appears to be a problem with the way that we're loading the row data into the name table. And in excuse me, in the previous streams, what we were seeing is that as we were loading the table data into memory here, basically what was happening was we were running out of time in the cycle, the short period of time between the previous frame and the next frame, and it was then creating that weird problem that we were seeing where it does that little jump. And then if you add in the excuse me, if you add in the attribute updates, it definitely doesn't do it in enough time. So what we need to do here is we need to get ourselves into a position where we have less stuff going on in the non-maskable interrupt, the NMI that happens at the end of vBlank. And the only way I can think of to do that at this point, after we've spent quite a bit of time trying to remove cycles from the way we are processing the scrolling, is to move that processing out of the interrupt and instead do that in the game loop, and then have the interrupt handle solely the process of actually updating the PPU. So before we get started, let's I don't know if there are any changes that we made between the committed version and this version. I just want to double check that, see what they are. Okay, so it's a minor one. I had added this variable to do frame counting, and just to make sure that the NMI and the game loop were actually being locked in sync the way that I wanted. So that's okay. We can revert that change to start clean here. One other note, for some reason Twitch is having a weird issue with the chat in the desktop web version. So last time I couldn't see any messages in the chat. I have my phone open here, so hopefully I'll see messages from anybody who's watching as we go along. Sorry about that from last week. So let's do this. So the first thing we need to do is we essentially need to I guess we kind of can keep the row loading check and the process scrolling stuff, but the bulk of this calculation is going to get moved out of here now, and we got to change kind of how that's going to happen. But let's do this, right? So let's move this here, or let's remove that, I should say. And we're going to make this do updates to the PPU based on what's calculated in the game loop, right? I don't know if there are problems. Skip row load. Where was that? Skip row load. Oh, that's interesting that it was doing that. Didn't really technically need to do that. So anyway, skip row load. We can leave those two labels there. They don't really cause an issue. So if we reload the game here, what we should see is that it will scroll, but oh, it's not even scrolling. Oh, I guess because I'm not incrementing the variable. So it's the sprites move, but not the background, which is fine. That's what I expected to happen. I just wanted to make sure that nothing unexpected happened, like with the update of the status bar or anything like that. All right, good. So let's go into the game loop now. Okay, so the game loop only needs to process the scrolling if we are in the gameplay state, which is here. It's going to add a lot of space here because I'm going to paste all this code in, and this is going to become a little bit messy. I just want to kind of visually separate it from everything else we're doing. So, all right. So we still want to do the same processing here with the scrolling. We want to check to see if we need to do the increments. And our subtractions and all this other stuff. All of this stuff is okay. What needs to change is we need to be able to indicate to the NMI that we actually need to do some sort of update to the name table. So let's see. So metatile flag, I think what we'll do is we'll rename this. I think. Oh, actually we can't because we're using that as the mask, right? Because I think metatile flag. No, okay. No, that's good. We can use that. So let's put something here. Non-zero if scrolling code detects that we need to load a new row or a new row of metatiles, right? And then I don't think we need this anymore, the metatile buffer. We're not using this anywhere, right? We're not. Good, so we can get rid of that. Metatile lookup we're still using, so that's good. That can stay. What we do need, though, is we do need a buffer to hold the new row of metatiles that we're working with and the new row of tiles, the 32 tiles we want to load across the screen. So we have something called new tiles. It's 32 bytes because it's the tiles across the screen. So what I'm thinking is in the game loop, what we'll do is we will write out a buffer of these 32 bytes, and that's our row that we're going to load. I don't actually know if we need one for the metatiles, the 8 bytes for the metatiles, because we can just keep looking those up like we're doing right now. It didn't seem like we were actually able to save much by doing the offset. The other thing we need to store is well, we have the attribute buffer. So what we need to do is we need to at some point load the content of the attribute buffer in the right location. All right. So let's see what's going on here. So instead of we're doing our work here for the scrolling, and then we don't want to change the location in memory that we're writing to, because we don't actually need to do that yet. What we need to do is we need to, let's see, we need to load metatile flag. Not load like that, you dummy. Load A, and then or A 02. So we'll set the second bit if we loaded a row of regular tiles. Actually, you know, yeah, no, that's fine, because what we would need to, yeah, sorry. So we need to differentiate between the fact that we loaded a row of meta tiles versus just a row of tiles that need to be loaded into memory. So this can go away. In fact, we will move that to NMI. We don't want to actually do this right now because it's wasted operations, but okay. So we're back here. I'm wondering if I want to change the behavior here and load 2 into this and just increment. I don't know that it really matters either way. We'll see. We'll see how it plays out when we're checking. So regardless of whether or not we're loading the meta tile, a new row of meta tiles, we are setting the meta tile flag. We're loading A with the row memory. Oh, we got to store this. We do need to store it because we need to know. And then, let's see, so we're going to do the lookup, and then we're going to shift it, and then we're going to clear and add mtile y. And then here's where things get a little bit tricky. We want to do the store not into 2007, but instead into tile row, what did I call it? New tiles. And I think it's Y, because Y is the offset into row mem. But that's only going to be 0 through 8. Right? Or is that's only going to be 0 through 8. X is going to be not what we need either, because X is going to be calculated based on the offset into the meta tiles, so we need let me think about how we can do this better. We could make new tiles point to a location in memory. I don't like, and then increment that location. But then not crazy about that. Why is 0 through 8 only? Right? My choices are what? We could use X. X. Oh, actually, no. Actually, wait. We could do that. We could do that. So we could use X, because what we can do is we can set carry and subtract M tile Y. We need to take the value of we need to know what the value of X is. Sorry, I'm thinking about how to do this and trying to explain it at the same time. So what we want to do is we want to make sure that we are incrementing this new tiles, or we're iterating through it from 0 to 31. This is essentially doing the same thing, but it's doing it based off of an offset from what M tile Y offsets it for, because M tile Y is the location in memory where the meta tile lives, and then we're incrementing one by one through all of the tiles that make up that. Oh, but you know what? It doesn't do it for 32. It only does it for it only does it 4 times because of the fact that the meta tile is only 4 tiles wide. Hey, Eugene. Yeah, it's going. We're rewriting a bunch of stuff here now, so it's getting a little hairy, but that's okay. So what I think I need to do is should I just keep X in a variable? I'm not using temp2, am I? I'm using it here. Well, I think all of this is going to have to get changed also for the meta tile, for the attribute. Well, I guess it doesn't have to be. Let's just have something called tile counter, and so let's store 0 into tile counter, and so what we need to do is we need to load at, yeah, we do this, and then so A has the value that we want, and we want to store that in there. We need the value of X. So if we push A, we push A, then we have that value. Then we want to transfer A to X, transfer X to A. I'm trying to do this with as little manipulation as possible here, but we're using Y to look up our meta tile that we're going off of, and then we're using X as our index into the actual meta tile. We guess we don't need Y again if we if we don't do the attribute stuff here. Let's comment this out for now, because I'm not even ready to deal with this yet. So what we're going to do is we're going to load Y tile counter, and then we're going to store A into new tiles Y. And then we're going to increment tile counter, which will be a value from 0 to 32. And then we're essentially done with the row load stuff. We're going to do that 4 times. Actually, so then we shouldn't do it this way. What we should do is that, and then we can increment y, and then when we're done, we'll store y in tile counter just to reduce the loads and stores because we're doing that repeat. And then, let's see. So that's good. And then we're modifying the screen memory so that it knows where we want to upload the new tiles to the PPU. Skip row load. Load meta tile flag branch not equal. This whole thing also can go away for now. Not completely, obviously, because we still will need to do this at some point, but now we've calculated the new row of tiles that we need to load, and then skip row load. Is that anywhere? That's over here. Okay, and then we skip there, we go to that, and obviously we don't do these updates. Okay, so that's good. And then in the NMI, what we want to do is we want to check to see if we have to update a row and then load that content. So we're going to load a meta tile flag. We're going to OR a with 2 to see if that's set or not. Branch if equal to skip row load. Otherwise, we're going to just do a simple loop here of load x0, repeat 32, store a, new tiles x, no, sorry, load a, new tiles x, store a into 2007 because we're loading that, and then end the repeat. We got to increment x, obviously 2, and then we want to load a with 0, oops, load a with 0 and store a into meta tile flag to clear it out for the next time round. Skip row load is already defined. Skip row load colon. So there's this one here. Do I still? Oh, I still have that. Let's call this skip row process because it's not actually loading it per se, it's getting it ready to process. Let's see. Let's make sure that it's not here again. Or still, rather. Skip row process. So this is, yeah, so all of this is just if we have to change which part of the name table. We're loading up 1483. Branch if equal to skip row load. Really? Or is it? $14.83. 1483. Okay, so branch not equal to load PPU row, jump, skip row load. Load PPU row. Okay. So I'm sure this is not going to work, but it should. The idea is that it should be loading the rows one by one in the game loop, and then in the NMI actually loading it into the name table when when a new row should be loaded. So let's see how bad this is. Okay, that's not, I mean, it's not right, but it's not totally wrong. It looks like it's actually loading some of the data properly. So let's take a look at what is going on here. It looks like it's missing some. Why would that be? I guess what we need to do is compare the breakpoints of the code that's handling the load of the table versus the breakpoints that are actually doing the loading. So let's see here. New tiles. So that would be here. I wonder if I'm just off by my calculation is maybe not right. Let's see here though. Rather than guessing, we can step through this a little bit. All right. So let's see. Let's slow down the emulation here a little bit. So it'd be nice if there was some way to see a visual indication of maps high E PC breakpoint EA88, this location. Go to this location. So this is, you know, let me move this, put that here. Draw bullet sprite. I think, so using the repeat seems to mess things up, unfortunately. So let's do this the long-winded way. Let's unroll it. Or you know what? Maybe let's make it a loop for now. We'll make it a loop so that it's just more straightforward. We can always unroll it later for optimization. Right now, I just want it to work right. Okay. So let's go to that location. Wait a minute, is this not get loaded? Oh, you know what? I think I changed the wrong thing. That's why. Oops. This one, I'll manually unroll it because it's only 4. The other one was 32, and that was just going to get messy. So, all right, let's restart that. so go to location. So that's that. And go to this location, and that's that loop. And load A. Yep, okay. So let's see what's going on in the event viewer now. That's not right at all. Load A, new tiles X, store A, 2007, increment X, compare, branch, not equal. What gives? It's a cool effect and all, but that shouldn't be happening. X is 8F. Why is X 8F? Jumping out of the NMI for some reason. It's taking too long just to do this. Wait a minute. How did that become 2-0? I'm confused. A, B, C, D, E, F, 2. Oh, damn it, I did it again. Keep doing that. You gotta compare X, not A. Okay, so the problem was that it was essentially looping forever in there, which is why it was giving the weird graphical results, because it was just loading garbage into the name table. Okay, so that's less bad, still not great. So what gives? I assume that the problem is now probably the screen mem isn't being incremented properly. Let's see. So we load, we increment this counter. Let's see. We do this, store Y. Okay, yeah, here's why we're not doing this. And then this, okay. So I forgot to properly handle this part of it, where it's updating the screen memory location. What's the matter now? It looked right for a second there. Skip row process screen memory. Let's see, compare it to 8. Oh. We do need Y, right? So what did I need to do here? Transfer Y to A, push A. And we do our tile counter work, we store it back, we pull A, transfer A to Y. That's basically, that was the problem, I think, because then our compare against Y wouldn't work. All right, let's try that again, shall we? What gives? Load A meta tiles X. Yeah. So we have Y is 0. Transfer it to A. Load A meta tile. Clear carry. Add carry. Okay. So A is good. A is okay to clobber there. Oh, wait a minute. This should be store Y into tile counter because I don't know what A is not going to have the value we want in it. So that's also no good. Let's disable this. It's a problem with kind of moving. It seems like with assembly, it's a lot harder to shift your code around because it's so very carefully dependent on the preceding code. Okay, let's see. Let's just restart this here. Go to there. All right, so now transfer Y to A. Tile counter should be 0. It is. Push it onto the stack, so 0 is there. Load Y with tile counter, which is 0. Load the meta tile, store it in new tiles. 0, increment Y, increment X. Store the next meta tile. Store the next meta tile. Store the next meta tile. Okay, so now we're going to store that Y in tile counter. We're going to pull that off the stack. And then we're going to transfer A to Y. We're going to compare it to 8. Next meta tile. So we're on the next meta tile. So, oh, okay. I still need to do this increment of Y here because that other increment I was doing was really for tile counter. So I think maybe we've got it. Let's just disable the breakpoint. I'm sure we'll probably need to come back here for a second. Okay, that was almost right. Looks like it might be off by a row in the beginning. I mean, it was definitely off because there's that gap, right? But I can't tell if it's the math is off. I assume that that's probably what it is, that the 8x8, the tiles are a lot prettier than last time. Yeah, they actually have a lot of the right color now. I had it working with all the right colors before, but that broke a little bit because it was taking too long to process that where it was. So I tried a bunch of stuff to optimize the code there, but that didn't end up working. Let me think. Why would this be off by... I guess this is off because... Oh, because... All right, so what's happening now what was happening before was we would update the row in the name table and then increment to the next row. But that won't work because now we're doing the write to memory, and then we're saying, okay, the next row you want to update is this row we're going to add to. So we actually have to, it's behind by 1 now. So what we need to do is we need to say A0, where aren't you in programmer mode? A0 minus 20 hex gives you 80. That should do it, I think. Pretty sure that'll do it. Wait a minute. Is it off by the same amount, or is it off by... Done loading tiles. Did it build that change? Oops. Let's try that again. So that should be this. Why is it getting garbage? Is everything off by a row now? Do I actually use this anywhere? Don't use this anywhere right now. Or at all. We can get rid of this for now. This is, let's load level. So in our code, after we load the level, we set everything up. So the screen, did I go the wrong way? Maybe I went the wrong way. I went the wrong way. That's what it is. Because we're scrolling up and not down. So what did I say? 802. So it's C0. And for those of you paying attention, 23Z0 is the attribute memory location, so we don't actually want to write there, and we won't. Hopefully, we shouldn't. It will actually do the decrement of 32 before we actually get a chance to do that right. There it is. That's what we wanted. All right, so now the tiles appear to be loading correctly. That's moving a lot more smoothly. So that's good. And now, let's see. We should start getting into that weird in and out pattern. Yep. Okay, cool. So that's looking good. That actually works. So, all right, so now we need to re-enable the code that's updating the attributes, and then we need to make it so that the attributes are only loaded when for that row that we update, or the 2 rows that we update, depending on the mode. So before I break anything else, let's commit this change. Tile meta tile row load is what's offloaded to game loop processing. So now we don't have to worry about, if I mess up that change, that we won't be able to return back to that easily. So cool. I gotta install Beyond Compare or something on here so that I can actually look at the diffs, because right now I don't have. Let's take a second here. I'll install. So KDiff 3 is okay. Beyond Compare is better, but this is free, and I can just do this right now, real quick. And it's nice that Source Tree knows about how to use KDiff3. It's just not as comprehensive, I think, but it's still pretty good. All right, so don't need the README. Then our diff, KDiff3, KDiff3. Okay, so yeah, so now we can look at, this is nice because you can see a side by side. You can scroll through the differences so you can see where we've made some major changes to the code versus what was there before. Beyond Compare has some nicer viewing modes and stuff, but anyway, we can do that next time. This was just faster, so cool. All right, now, so the nice thing is that this is also simplifying our VBlank, right, our NMI, because we are doing the heavy lifting during the frame drawing, which is what we want. We have more time during the frame draw than we do between frames. So what we want to do is with each loop, we want to update what needs to be done on the screen. And then when it gets time to actually draw the new frame, the information is just ready to go. So we, like in this case now, all we're doing is we're saying, okay, just take the locate. If we saw that we have to update the screen, just grab the location, store it into 2006 so that we are updating the appropriate location in the name table. And then we are just simply looping through and updating 32 times. And now that we know that this part works, what we can do is the following. We can unroll this whole loop, and that will be even faster. Because the branch, compare and branch, the compare isn't, I don't think, that expensive, but the branch operation is, and so doing that 32 times is unnecessary since it's a fixed interval. And you can see that works just as well as before, but it's definitely going to be more performant. So cool, that's good. It's not doing those weird sort of jittery motions that it was before, where it looked almost like it stuttered back for a frame. All right, so now we got to calculate the attribute stuff that we were not doing, and then hopefully if we can get that done, we'll call it a night for today, because then we have a lot more to do. I mean, there's always a lot more to do, but there's even more to do. I had this crazy idea that somehow maybe I could make this code work. Make this code work for both PC and NES by splitting up the relevant portions. So having the core game updates, and that's part of the other reason why this actually works better. Having the core updates work on purely just memory and manipulating the memory, and then let the NMI handle the actual updates rather than interspersing them here within the code. And then that would potentially make what I'm thinking possible, because even if I had to write something to simulate the 6502, that in and of itself, just emulating a 6502 processor, is not nearly as hard as doing the is doing the emulation of the PPU. That's like really where it becomes kind of crazy and complex. And so what I was thinking is that, you know, it could set up the memory appropriately for what needs to be drawn, and then have just standard sort of C code on the PC side that reads that memory and figures out what to draw and make that separate from what we've got here. But anyway, that's kind of all getting ahead of everything. So what I think I want to do, what I did before, which is move the attribute load stuff out of this here, because I feel like it's a lot of code, a lot of unnecessary checking. So if you were on the previous stream, what I ended up doing was I made the code stop checking the attribute flag every loop, and instead move that out so that it was done once the metatile load was done, just to reduce the amount of times we had to check that. And that seemed like that was better. It's certainly unnecessary to check every time. It's not going to change with every loop. Once it's set, it's set. So no more metatiles gets called. And then we can load this, and then we say, okay, if we're not doing this, we want to skip the attributes, which is here, which is fine, because now we're going to update the screen memory position. So then what we want to do, I want to load y with 0. All right, we're going to increment through our row mem again, and we're going to load the value, because the value will tell us, let's see, so there's a separate I believe there's a separate palette lookup is what we did. There's metatile lookup. Oh no, that's right, we remapped every metatile so that the palette matches the metatile number, so we don't have to even do anything. So we load that. So this is good. All of this, I think, is actually fine. Oh, is it? Grr. Okay. So we're going to compare that. I think all of this code is good as is. The reason I'm doing this line by line is because I'm kind of reading it as I go. Yeah, that looks right still. I don't think there's anything that's wrong with this. And then we're going to increment y. Well, so let's see. We're going to load it. We're going to do this. Skip the tile fix. We're doing this calculation. We're storing into attribute buffer. Compare if it's split. Then go to done with attributes. Increment this. Increment y. Compare y with 8. Branch if not equal to. I'll just say branch if not equal to skip attributes, which is more meaning just we're done with the attributes. Otherwise, we're going to jump. Wait, no. Branch if equal to skip attributes, and then otherwise we're going to go back up to. I'm going to add another label here just so it's not confusing or any more confusing. We'll call this, well, we've got to do that anyway because we don't want to reset the y. Next metatile attribute. That, okay, so let's make sure that that didn't throw things into an infinite loop. Oh, it broke things. Okay. Why did it break things? Why did it break things? Skip attributes. No more meta tiles. Load Y 0. Load a meta tile flag. Branch if equal. Oh, it wouldn't necessarily be equal. Yeah, okay, yes, that's fine. Well, yeah, okay. So load Y, load the row memory, again, store, do the decrement that we need to do. Because the palettes, there is no 0 palette. So let me make a note of that here, just because I know I'll forget it at some point. Decrement is necessary because there is no 0 palette. Just there is no meta tile 0, so the first palette is at index 0. All right, so then we're going to load temp back, and we're going to compare it to FF to make sure that we didn't accidentally offset that the wrong way. We'll fix it if we need to, meaning there was a potential. Let's see, let me just make sure that this is in 2 places. 4 places. Why? Why is it in 2 places? What is this? That's weird. Oh, but that's in a different scope. Okay, never mind. That one is a different one. Okay, so load a 0 increment temp, ASL, or a temp. Yep, all that is fine. What is X supposed to be coming into here? That is the question. Or okay, we're transferring it from attribute index. That's fine then. All right, maybe we'll just we'll step through this because I'm not seeing anything obvious just by looking at the code. So sometimes you got to walk through it, and that makes it easier. So let's see, done with attributes. So where is the code where we do the check? Here. Okay, so let's restart the game. Run it. Okay, hit start. So meta tile flag 7. Really? Why would it be 7? Load a meta tile flag. Byte value 3. That's weird. Why is, well, it's not 0, so that's fine in theory. Let me restart here. Something is not quite right. Okay, that's still the right breakpoint. Let's start. Okay, load Y0. Load a meta tile flag 3. Okay, so it's gonna start looking. So rowmem, okay, store that in temp, decrement temp, which is now 0, load a temp, compare it, we didn't roll over, so branch not equal to skip. Okay, so we skip that tile fix, and we do shifts, and there's nothing else to do, so we're good. Yep, ASL, or a temp. Yeah, ASL or a temp. Oh, wait, that's weird. Why did it go into no? That's strange. Why is it showing initialize sprite loop? Store a temp. Is this some sort of weird problem with the debugger? Let's see. Looks like it is. It looks like the debugger is confused. Probably because of the repeats that I have. This kind of stinks that that causes that problem. It's for the sake of my sanity, let's make sure that we can actually see this properly. Oh man, 64. Fine. Let's just do this. Load x0. Well, it should be, it is already 0. What's 64? It's 40 in hex. And then, do we have any more repeats? This one. One, two, three, four, 5, 6, 7, 8. Oops. 8. That's not used. This one is later on in the code, so I don't care about that. All right. Let's see if that makes the debugger less confused about what's going on in the game. All right, so I want the code for skip attributes, done with attributes, skip mask change, next, no more meta tiles, no more meta tiles. Definitely looks correct now. Before it was, unless I just missed something, it was looking odd. So, all right, so get rid of this. All right, cool. So load our meta tile flag, load Y, do all that stuff we were doing before, load the attribute index, transfer that to X, load a temp, attribute mode, okay. So it's all storing it into the buffer. Load a attribute mode, split, branch not equal, transfer X to A. Set, subtract. Yeah, this all looks right so far. Yeah, that seems right. So what is the problem? Go to the game. That's looking okay. That's looking okay. Now it's not okay. So what got messed up? Let me see something here. So what's updating ROMEM? Something must be updating ROMEM. Am I doing that in NMI still? No, okay, that's doing that here. That's fine. Just something about when I enabled the attributes, that was what's causing the problem. Let's see. Probably just something stupid. Store it in temp and then do all this garbage. X is the attribute index. Is it possible X is getting clobbered somehow incorrectly? X is equal to 4. But that's... yeah. So it jumped into that problem loop because something had gotten corrupted. So let's... I want to look at what attribute index looks like when we're here, or what the X index looks like. So it's 38, 30, 39. That shouldn't be increasing. So, oh yeah, okay, no, it should be increasing with each attribute update we do. Oh, but we're not, okay. That's the key part that's missing here. So all of this still has to happen. So okay, so and then this update attribute PP, you can all go away. Okay, so yeah, so the part that we were missing is that once that's done, finalize attribute updates. Once that's all done, we actually have to look at the attribute index and offset it properly, and then based on where we're at with the attribute index, we have to determine what split mode we're in, because we are updating the attribute index in 2 different split modes. So okay, so that not in range. Branch, carry clear to, so this is a jump. Yeah, we'll just do this. Where? 898. 898. 898. Branch if equal. Okay, so branch if not equal to this. Otherwise, jump to that and then do this. So these are just nameless labels, essentially, where I'm just saying go to the next label, whatever it is, without a name, just to be able to do this jump because it's out of the range of address space that we can use with a branch. Okay, so let's see, where attribute index, let's do it here. So 38, 39, 3A, B, C, D, F. And then we should be done at this point. Compare it. We finalize the attribute. So load attribute index, it's that. We're going to subtract that, and then we're going to wrap it around. We're going to store it, and then if the carry is clear, yep, good. That means we don't have to change the mode for the attributes. And then we update the screen memory. So we should be good. It's still not going to have the right colors yet. That's looking like it's okay. Maybe where, let's see where this looks like it's fitting within the frame, shall we? So we're here, and then once all the attribute stuff is done, we are here. So let's make these just marked and look at the event loop. Let's see how this is looking. So it's happening down there, but that's okay because that's not, so while that's where the NMI technically happens too, the NMI is taking care of the loading. That's all looking okay, I think. Okay, because yeah, so what's happening is the NMI is happening really quick when we don't have to load anything. And then it's allowing the game loop to run. But then when we do have to load things, it's making the code from the game loop that processes the tile information. That's running as we draw the next frame, which is fine because we've got the data, so it's already loading it into the, it already loaded it into the PPU properly. It's just that it took a little bit longer to relinquish the control from the NMI back to the main game loop. And so now we would go back into updating, you know, our game loop some part over here in the frame, but that's exactly what we wanted. We didn't want the update itself to happen when we were already at this part of the screen. So that seems good. I'll have to test this on an actual NES and see what that looks like. So now the only thing we need to do is actually update the attribute table, and I'm wondering if we can do that crazy thing that we were doing before, just for the sake of getting it done. So that updates the 32 tiles, and then Let's do this. Bit 2002 load A, 23 store A in 2006, load A C0 store A 2006, repeat 64. So what I'm doing is I'm just going to do a full dump of the attribute memory right into the PPU. I don't know if that's going to work, because I don't know that that's really ever going to have enough time to complete. But now that we're not really doing anything else in there and we're just processing the stuff outside of the NMI, it might. So it's kind of working. It's like progressively off a little bit, but updating the attributes to be what they're supposed to be for part of the screen. That's really interesting. That's kind of awesome. That's not what I wanted it to do, and that's certainly not right, but it's still cool that it's working and it's not creating any sort of weird screen artifacting in terms of like the updates or, you know, the sort of gross tile tearing we were getting. So why is that happening? Could be that the attribute buffer stuff is wrong now. Let's think about this for a second. So the initial update to the attribute buffer is correct in that it's storing, it's going to store the entire attribute buffer in for the first screen. And so if we reload the game for a second here and pause immediately, this all looks right? These gradient tiles, granted the background color is not right, but that's because the background color was forced to black. So that is correct, and the problem is, it seems, is that something is off in the way that we're loading it into memory here. So let's think about why that would be. So 38, this is probably the same issue as before. Oh, wait a minute, you know, this sort of seems like I wonder, this sort of seems like it's updating too quickly. Like we don't, I wonder if I'm updating it too, yeah, okay. I'm updating it too often because we're just checking to see if the meta tile flag is set to some value that isn't 0, but really what we should be checking is the meta tile flag set with bit 1 set, because bit 1 is going to say we're doing a new meta tile row. If bit 2 is set, then then it's just a regular row. So what we actually want to do for, let's see, where is that? For this, we want to load it, and then we want to I always forget, is there a way to do that? There you can do an increment X and an increment. So let's do this. Decrement X, compare X with 1. So if the value is 1, if the value is just 1, let me think about that. I guess we want to look and see if the value is 3, because we're going to have to load, yeah, okay, never mind. So this is actually a compare with 3. So branch if not equal to that, meaning we've loaded a new meta tile row and we have to load a row, so we've got to load the attributes. So I think that'll fix it, because that was the issue. It was loading the meta tiles too quickly, the attributes too quickly. Right? Still getting the same behavior here. Hold on a second. Oh, I did the same dumb thing. Compare X. Well, because actually I wanted it to load A. That's why. Okay. No, it's better. It still seems like it's off a little bit. Let's see. And I can't believe that it's actually loading the whole attribute table correctly in every frame, every 8 pixels. Am I not doing what I think I'm doing? So meta tile flag gets initialized to 0. If we need to go to the next sub row, jump load new row. Okay, so if we load a new meta tile row, then we're just incrementing meta tile flag. If we're loading a whole new row, we're loading with meta tile flag, and we're doing an OR A, and then we're storing it. But that, yeah, that's fine. So we're gonna have bits 1 and 2 set, excuse me. So then that value should be 3 if we're loading a new meta tile row, and the meta tile row is just if 1 is, it has to have 1 set. So compare this to 3. If it's not equal, oh, that's why, because the logic changed. So if it's equal, it's going to go to that processing. Otherwise, it's going to, there we go. Nice. All right, now we actually have our attributes loading correctly. Now this is not optimal because we're literally, every time we load a new row of attributes, we're reloading the entire attribute table. But that's the thing with the way that this is working, right? Is that now we've divided up the tasks where it makes the most sense, right? We have all the row and attribute processing being handled in the game loop where there's more time, and the NMI is handling just video or graphics related tasks. And we can optimize that by shortening the amount of updates that we have to do, because it's kind of ridiculous that we're doing a full update to the attribute table every time we hit 8 pixels. But let's see. If we slow this down, we should see that we are not seeing updates to the PPU over here, which is exactly what we want, because that means we've got that working perfectly now. All the PPU updates are happening in here, and granted, again, I think these red ones are probably the attribute updates for, are these happening more often than they need to? Are we updating every frame? Shouldn't be. Let's see. Two is we've loaded a new meta tile row. Oh, I'm looking at the wrong. No. Or A2. 2 is the new row. Right, so we only need to do this part. Load a meta-tile flag or a 01 branch not equal to load skip row load. So if we haven't compare to 1. So if we don't have a new row of meta tiles, which is 1 for that value in meta tile flag, then we don't need to do anything. We just skip this. So that should even be better. Colon expected. Oh. Okay. So now in the event viewer, we should see fewer updates occurring overall, just more spaced out. Yeah, so you can see there is a slight dip in activity between loading the rows, it looks like, because we're not loading the attributes every time. Let's see, I got that right? Loading the row is for if 2 is set. Meta tile flag aura 2 load PPU row. Otherwise, I'm gonna make this otherwise skip row load, right? Because if 2 isn't set, then we definitely don't have the meta tile. We don't have to update the attributes because we didn't even load a new row into memory. So there's the screen memory storage. We update with 32 repeats. Then we check the meta tile flag to check if bit 1 is set, and then we compare that to 1, and then we I guess we can just say branch if branch if not equal, and then jump, and we do our updates there, and then we need to do that here. See, that should make it even more correct. Let's see here now. No, now it looks like it's doing the updates like before. Should have left that alone. Okay, so I mean, like I said, it's doing a lot of updates, more than we need to over here, and so what we can do is we can reduce those updates by not updating the attribute memory on every single by not updating the entire attribute memory table location. But even with doing that, this is working well. So I guess what we need to do at this point is in the next stream, what I'll do is I'll make this so that we don't do the full 64 byte update. We only update the row that we want, and then from there we need to start planning how the levels will. Oh, well, we got to get back to the original reason we were in this to begin with, which is that we were going to do collision with the map, right? And the reason we were saying we need to make this change was because I want to be able to annotate that, you know, this meta tile is collidable. And so we'll sort of have two levels of collision detection, right? We'll have the sort of broad collision detection that if you're over a meta tile that nothing in it is collidable, we won't even bother checking the individual tiles. But we then, let's say we had something, and that brings to bear the fact that we need some real meta tiles that have a little bit more nuance to them, maybe something that looks like we can actually fly around it. So whatever that shape may be, we will want to have something that has our tiles in here and maybe just has a section of it that's collidable, right? This part here. So then the meta tile itself will say, yep, I have something that's collidable in it, and then we will look and see, we will compare the player's position to the collidable tiles within the meta tile, and then if that collision occurs, then the player will die. And the whole reason we did that, this rewrite of all of this stuff, was for this, because basically we couldn't do that with the previous method where we were loading the screen in chunks that were sort of reverse streamed in without any sort of way of looking up the context of where the player is, and doing an easy lookup based on the player position. So that's what we'll do for next stream on Thursday. Good progress here. I'm pretty happy with this. Let's see if we spawn some enemies. That's all looking pretty good. I mean, I'll try it out on a real system here, but I'm pretty happy with that. So hopefully by next stream, Twitch will have the chat situation figured out, and I'll actually be able to see chat on my other monitor and not just on my phone. But as always, if you have any questions, feel free to tune in to the next stream on Twitch. Reach out to me on Twitter at Clairvis. These videos get posted on YouTube after the live stream. You can post comments and questions there. I'm behind on the next Zero Pages video just because things have been busy here between work and summer and everything, so I will try and get that one loaded up. I know what I want to put in it, and it shouldn't be too hard to do, but yeah, thanks for watching, and I will see you next time.